This is the Beverly clock on the third floor of the physics department at the University of Otago, New Zealand. It's only been wound once since the time of its construction in 1864 by New Zealand watchmaker, astronomer, and mathematician Arthur Beverly. And it's still running 157 years later. Unlike most weight-driven clocks, the Beverly clock doesn't have to be manually wound because it uses changes in temperature and atmospheric pressure as a mechanism to wind itself. Inside the clock is an airtight box with a cubic foot of air inside. I couldn't find a good picture or diagram of the airtight box inside the Beverly clock, so this is the inside of a modern version of an atmospheric clock called the Atmos clock. When the temperature changes, the air inside the box expands or contracts, and that presses on a diaphragm. And that expansion and contraction is used as a winding mechanism. A temperature change of about 6 degrees Fahrenheit over the course of a day is enough to lift a 1-pound weight about an inch, and that's enough to keep it running for the rest of the day. Although it's only been wound once since its construction, it hasn't been running continuously. Every now and then, the clock is stopped by the physics department to clean or calibrate it. Sometimes the physics department moves location and the clock moves with it. And sometimes there isn't that 6-degree change in temperature that it needs for the day. But when the repairs are done or the temperature goes back in sway, the clock sparks right back up.